Have you ever noticed how your breath seems to vanish into thin air on a warm summer day? It's almost like it disappears completely, leaving no trace behind. But step outside on a chilly winter morning, and suddenly, your breath transforms into something magical, a swirling cloud of what looks like smoke. It's like breathing out a miniature cloud, a puff of your own personal weather system. This fascinating phenomenon, my friends, is not magic, but the incredible science of condensation at play. It's a reminder that the air around us, though invisible, is a dynamic and ever-changing mix of ingredients, much like a recipe for a delicious cake. And just like the right combination of ingredients can lead to a delectable treat, the right atmospheric conditions can create this captivating display of steamy breath. But what exactly is happening when your breath turns visible in the cold? Why don't we see it in the summer? To unravel this mystery, we need to delve into the fascinating world of water vapor, a key player in this everyday spectacle. So we've established that the air is full of invisible water vapor. But how does this invisible vapor turn into the misty cloud we see when we breathe out on a cold day? The answer lies in a process called condensation. In simple terms, condensation is the process where water vapor in the air changes from its invisible gaseous state back into liquid water. Imagine a crowded room full of people dancing energetically. That's like the air around us, filled with energetic water vapor molecules constantly moving and colliding. Now imagine the music slowing down, and the dancers start to pair up, holding on to each other. That's similar to what happens during condensation. When the temperature drops, those energetic water vapor molecules slow down and get closer together. As they huddle closer, they lose energy and transition from their free-spirited gaseous state to a more condensed liquid form. This is what we see as tiny water droplets forming a visible cloud. And that, my friends, is the essence of condensation. Think of water vapor as tiny dancers, twirling and swirling in the vast ballroom of the atmosphere. These dancers are always present even though we can't see them. On warm days, they're like energetic jitterbuggers moving quickly and independently, taking up a lot of space. This is why warm air can hold more water vapor. It's like a spacious ballroom accommodating more dancers. But as the temperature drops, the music slows down and our dancers slow their pace, getting closer together. They transition from energetic jitterbugs to slow dancing partners, holding on to each other. This is similar to what happens when water vapor condenses. As the temperature cools, the water vapor molecules slow down and move closer together. They no longer have enough energy to stay far apart in their gaseous form. They start to clump together, forming tiny liquid droplets like dancers pairing up for a slow, graceful waltz. And just like that, the invisible becomes visible. Condensation isn't just about our breath turning visible in the cold. It's a fundamental process in nature, responsible for everything from fluffy clouds to refreshing rain. Remember those tiny water droplets that form when water vapor condenses? Well, when these droplets become large and heavy enough, they can no longer stay suspended in the air. Gravity takes over, and they fall back to Earth as rain. It's like our slow-dancing water vapor couples getting so cozy that they form a big, happy group hug, becoming too heavy to stay afloat. Condensation is also what causes dew to form on grass and leaves in the mornings. As the temperature drops overnight, the air near the ground cools down too. This cooling causes the water vapor in the air to condense on the cool surfaces of the grass and leaves, forming tiny sparkling beads of water. It's like the air, tired after a long day, drapes a refreshing blanket of dew on the sleeping plants. Now let's bring the focus back to our breath. Why does it turn visible in the cold but not in the summer? The answer lies in the temperature difference between our warm breath and the cold surrounding air. Imagine stepping outside on a frosty winter day. The air outside is crisp and cold with those water vapor molecules moving slowly like sleepy snails. But when you breathe out, your breath is warm and moist, like a cozy sauna, carrying a higher concentration of those energetic, fast-moving water vapor molecules. When this warm, moist breath hits the cold air, something incredible happens. The water vapor molecules in your breath encounter the slower, colder air molecules. This sudden encounter causes the warm water vapor molecules to lose their energy quickly, just like a fast-moving car slamming on the brakes. They slow down, huddle closer, and lose their ability to remain as invisible vapor. Now let's talk about a term you might have heard in weather reports, the dew point. The dew point is like a saturation point for the air. It's the temperature at which the air can no longer hold all of its water vapor. Think of a sponge. You can keep adding water to it and it will absorb the water up to a certain point, but once the sponge is completely full, any more water you add will simply spill out. The air is similar to the sponge. It can hold a certain amount of water vapor at a given temperature. The dew point is the temperature at which the air is like that fully soaked sponge. When the air temperature cools down to the dew point, it becomes saturated. It simply cannot hold any more water vapor. And guess what happens then? You guessed it, condensation. So let's put it all together. When you breathe out on a cold day, your warm, moist breath containing a higher concentration of water vapor meets the cold air. This cold air might already be close to its dew point, meaning it's almost saturated with water vapor. The warm water vapor molecules in your breath collide with the cold air molecules, losing energy and slowing down. This cooling causes the water vapor molecules to reach their saturation point like a sponge that can hold no more water. As the saturation point is reached, the water vapor molecules can no longer exist in their invisible gaseous form. They transition into liquid water, forming tiny visible droplets. These droplets, suspended in the air, create the cloud we see as our breath. And there you have it. The mystery of winter breath is solved. It's a beautiful example of condensation, a simple yet powerful process happening right before our eyes. Condensation isn't just limited to our breath in the cold. We've all seen it on our windows on chilly mornings. Those tiny water droplets clinging to the glass, making it look like the windows are crying, are a result of condensation. On cold days, the temperature inside our homes is usually much warmer than the temperature outside. The warm air inside, which often carries more moisture from cooking, showering, or simply breathing, comes into contact with the cold window surface. Remember our sponge analogy? The cold window surface acts like a chilling chamber for the warm, moist air. As the warm air near the window cools down, it reaches its dew point, and the excess water vapor condenses on the cold glass surface, forming those familiar water droplets. So the next time you see your windows crying, don't be sad. It's just condensation, a natural process reminding us of the invisible forces at play around us. Another classic example of condensation in action is the fog that forms on our bathroom mirrors after a hot shower. Have you ever noticed how the mirror steams up, obscuring your reflection in a misty haze? It's like stepping into your own personal cloud. This fogging is, you guessed it, condensation at its finest. The hot water from your shower releases steam, which is simply water vapor at a high temperature. This steam fills the bathroom, increasing the amount of water vapor in the air. The mirror, however, remains relatively cool compared to the steamy air. When the warm, moist air comes into contact with the cool mirror surface, the water vapor molecules in the air cool down and reach their saturation point. Just like with our breath and the windows, this cooling and saturation cause the water vapor to condense into tiny liquid droplets on the mirror surface, creating the fog. So, the next time you find yourself wondering how the bathroom mirror got so foggy, remember the hot shower, the steam, and the magic of condensation? Condensation isn't just a science lesson, it's happening all around us, playing a crucial role in our daily lives and the world around us. Think about the clouds in the sky. Those fluffy white giants are formed by condensation on a massive scale. Warm, moist air rises from the Earth's surface and cools as it ascends. As the air cools, the water vapor condenses around tiny particles in the air, forming clouds. Condensation is also essential for the water cycle. The water vapor that condenses to form clouds eventually falls back to Earth as rain, snow, or hail, replenishing our rivers, lakes, and oceans. From the formation of clouds to the life-giving cycle of water, condensation is a fundamental process that sustains life on Earth. It's a constant reminder that even the simplest everyday phenomena can be explained by the elegant laws of science. So, the next time you step outside on a chilly day and see your breath turn to steam, take a moment to appreciate the science at play. It's a reminder that the world around us is full of wonder, and even the simplest observations can lead to a deeper understanding of the natural laws that govern our universe. It's also a testament to the fact that science is not just confined to textbooks and laboratories. It's happening all around us, all the time, in the most ordinary and extraordinary ways. All we have to do is open our eyes, ask questions, and be amazed by the world's wonders. Keep exploring, keep questioning, and keep the spirit of scientific curiosity alive.